Welcome to History Repeated. Hi, I'm John Myers, and today's video will help you understand your Ancestry DNA results. Getting back your Ancestry DNA results can be a really exciting thing. But going over the basics of how genetics pass on information and traits about our ethnic background is a good thing to understand. If you haven't already, please take a second right now and subscribe to this channel so that you'll know when new videos are uploaded, and we'll have a topic of interest to you uploaded soon. In this video, think of it as a reminder of something that you may have covered in high school biology class about how genetic traits are passed on, and how not all genetic traits are passed on from all of our ancestors, and how you can actually improve your results by asking family members to take the DNA test along with you. So let's look at some of the basics of how traits are passed on now. I'll show you an example of ethnic DNA code with my tree and my parents and my grandparents, my great-grandparents. I'm going to block out the information, and on my dad's side I'm going to put in some numbers, and this will represent ethnic DNA code that can be passed on through the generations. On my mom's side I'll do the same thing, but I'll use letters so that we can keep it straight which side the information is coming from. On my dad's side, information gets passed on to my grandparents and a little bit from each one of their parents. And on my mom's side, the letters get passed on. So that on my dad's side, the information now gets passed on to him. And even at my dad's generation level, if we take a look, we'll see that he got information from two of my great-grandparents, but two of my great-grandparents didn't pass on any information to my dad. Well, let's say my mom makes out a little bit better, and she gets a better sampling of ethnic DNA information from my great-grandparents on her side. Nevertheless, I'm going to be limited in what I can receive from my parents because I can only get half of my genetic information from my dad and half from my mom. Let's see what I get. So in my case, I'm going to get some DNA from each of my parents that represents my ethnicity. And again, my dad only had a certain amount that he could pass on to me. And if we see what I got, we'll see that I got all that he could give me, which was two of my great-grandparents on his side. And on my mom's side, I only got two of my great-grandparents on her side. Nothing from my dad's dad, my dad's mom's mom, my mom's dad's dad, or my mom's mom's mom. The only way I can expand my knowledge of my ethnicity then is to have more of my relatives tested. So we'll look at my brother and my sister, for example, or aunts and uncles. You can see now that I filled in some of my mom's information, but no more of my dad's. I'd have to go back some generations and see if my grandmother could add anything to it if she were still alive. The whole point is you're not going to get all of your information passed on to you. You're going to become whatever is the dominant trait passed on to you, and that's what you're going to identify with. But to get a more complete idea of your entire ethnic background, you've really got to have more of your family members tested. So I hope that explains why your ethnic background may not appear totally in your DNA test. You don't get all the ethnic information from your ancestors, and that's why it's a good idea to ask as many of your family members as are interested to be DNA tested as well. That will help broaden the knowledge you have of your ethnic DNA background. Next, I want to talk about one more subject, and that is this idea of dominant traits versus recessive traits. We tend to identify with our dominant traits, the ones that we exhibit. For example, I've always been identifying as blonde-haired, blue-eyed, and I don't know if these traits are dominant or recessive, and my spouse might have dark hair and dark eyes, and again, we don't know which ones are dominant. But then when you have children, you find out that, oh, they look more like my spouse than me, or they don't look like either one of us. And how is that possible? Well, it's this idea that we get a gene from each one of our parents, and some of these traits are dominant and some are recessive. And then depending on what the mix is, depends on what we exhibit, and that's what we tend to identify with. So this will be a reminder of how that works and hopefully answer even more of your DNA questions. Don't forget to hit the thumbs up on this video and subscribe to this channel. Let's look at what we call dominant and recessive traits. Sometimes we look like our parents, sometimes we have the same traits as our parents, and sometimes we have different appearance. Things like hair color or eye color. Even our height and health can depend on what traits we get from our parents. When we talk about traits, we get them through our DNA. Our parents pass on genes which determine our traits. We get half of our traits from our father, and the other half we get from our mother. Now let's say that we get brown hair trait from our father, but our mother has black hair traits to pass on. Which will we have? And the answer is whichever trait is called dominant. Well, let's look at that and see what we mean by a dominant trait. First, how we represent it. A dominant trait will be a capital letter, and for the other kind we'll use a small letter, and we'll call that one the recessive trait or the recessive gene. Dominant traits are the always noticeable traits, and they're stronger. Recessive genes are less stronger and only show through if two are present, or if we get one of each from our parents. So let's look at our father. He carries 2 genes per trait. He could have 2 dominant genes for a trait, for example. He could have a dominant gene and a recessive gene for a trait, or he could have 2 recessive genes. Likewise, the mother could have 2 dominant genes for a trait, one of each kind of gene for a trait, or 2 recessive genes for a trait. Now notice, because it's stronger, the dominant trait will always show through, even if you only have 1 gene for that trait. The only way to show the recessive gene is if you have 2 of them, because it's less strong. The way we determine what a child will have, since we don't know what kind of genes our parents have, a child could have 2 dominant genes for a trait, or one of each kind of gene, or have 2 recessive genes for that trait. So we set up a table of possibilities, and we presume both parents have dominant genes for each trait. What can the child have? Well, inside this table, we write down 1 gene from each parent, and we see that the only possibility in this case is that the child will have 100% chance of getting 2 dominant genes. Now, if the dad has 2 dominant genes, but the mother has 1 of each kind of gene, we'll set up the table for that. And we'll fill in the table with possibilities of the child getting 1 gene from each parent. Here, the child has a 50% possibility of getting both dominant genes, but a 50% possibility of getting 1 of each kind of gene from the parent. Well, what if the dad has 2 dominant genes and the mom has 2 recessive genes? Let's set up that table. Here, the child is going to get the dominant gene from the dad, the recessive gene from the mom, but always show through the dominant gene trait. But there's 100% chance that the child will have 1 of each kind of gene. Now, if the dad has 1 of each kind of gene, but the mom has 2 dominant genes, it's the same as the one in step 2 of this table, except the other parent has the dominant gene. The child will have 50% chance of getting 2 dominant genes, or 50% chance of getting 1 of each kind of gene from the parent, and the dominant trait will show through. Now, what if each parent has a dominant and a recessive gene? Well, we'll make up our table. Here, the child will get 2 dominant genes, a dominant and a recessive, and here the child will get 2 recessive genes. So 25% chance of getting 2 dominant genes, 50% chance of getting 1 of each, and a 25% chance that the recessive trait will show through. If the dad has 1 of each kind of gene and the mom is totally recessive on a trait, the child can get 1 of each kind of gene, or 2 recessive genes 50% of the time. And remember, if 1 gene is present that's dominant, it will show through. It takes 2 recessive genes for that trait to show through. Now, if the dad is recessive and the mom is totally dominant, well, that's the same as the 3rd step down in this table, except the other parent has the recessive genes. The child is guaranteed to get 1 of each kind of gene from each parent. 100% will be a carrier of the recessive trait but show through the dominant trait. If the dad has recessive genes and the mom has 1 of each, well, 2 steps above, we've seen this case the other way around. The child could get 1 of each or 2 recessive genes. 50% chance of the dominant trait showing through, and a 50% chance the recessive trait will show through. And the last case is where both parents are recessive in their traits. We'll set up the table for this. It should be obvious what the results will be. The only genes that the parents can pass on are the recessive kind. So 100% chance the child will get the recessive gene and that trait will show through. So that's how dominant and recessive genes are passed on. We may get a trait that looks like our parents. We may get a combination of genes that weren't present in our parents' appearance, but that they were carriers of in the case of recessive genes. Also, when we go back to look at ethnic traits and our ethnic DNA, this is why sometimes our parents look like one thing and we might look like another thing. It's because of the genes that our parents pass on to us. Hope you've enjoyed this video. Give it a thumbs up and don't forget to subscribe to this channel.